I am the researcher at the Bonn Alliance for Sustainability Research, Digitalization and Sustainability project based in Bonn, Germany. And I am happy to hosting this session for you and looking forward to your engagement and participation. Well, the session called Smart Water Technologies and Digital Solutions to Advance Water Security. We're moving towards a water secure future. Just to give you a very short presentation before the session starts, I am going to just talk about the overarching topic that we are trying to address in this session. Well, starting with the global changes that we know all, starting with the urbanization and modernization, rising expectations due to the population growth, and lots of social transformations, climate change, as we know, and disruptive technologies. So we are facing all these changes, and these dynamic changes are impacting our everyday lives. Well, so where are we heading when we are facing all of these different external factors impacting our day-to-day lives? Well, we have a roadmap, we know the global goals. And now we have to think about how sustainable development in the time of the changes that we already addressed and we talk about is going to help us to make sure that everyone's on board. Well, multidisciplinarity, multi-stakeholder approaches can just lead us to inclusive approaches when we make sure we leave no one behind. Focusing on the Sustainable Development Goals, as we know, we talked about it a lot, and of course, we had lots of sessions during this event focusing on the SDGs. So we know generally there are 17 goals, 169 targets, and 232 indicators, and we have another, now it was just for 15 years to reach them, and now we are in 2021, and we have only 9 years left. Well, in this session, we are focusing on SDG 6, the goal dedicated to clean water and sanitation with 8 targets. And we have a very great session to address the digital technologies and the role of data in achieving and contributing towards achievement of these targets and as a use cases. So talking about different projects and researches to just see how each of us individually using these technologies, and we are trying to make it sustainable enough for achieving the goal number 6. Well, let me just get back to the introducing our presenters. I have to stop sharing the screen. Well, our first presenters, well, let me just first give you a very short structure of the session. We have 4 oral presentations, each will take maximum 10 minutes, and we have 2 interesting poster presentations. And then after these presentations finishes, at the end of the session, we are opening the debate for discussion and if you have any question addressing each of the presenters. But meanwhile, you can use the chat box to ask or refer to any of the presenters about any question or comments you have, and then we will get back to them at the end of the session. Well, I am going to ask Miguel Valeo Orti to share his screen for his presentation. Meanwhile, I am introducing him to you. He's pursuing his PhD at the Institute of Geography at Heidelberg University in Germany. He has been meanwhile lecturer at the Department of Geospatial Sciences and Technology at the University of Science and Technology in Namibia. Well, he's going to talk about mathematical methods based on Poisson point process, machine learning, and Kalman filter to predict and describe next drought in Namibia as a tool for farming management. Miguel, please, the floor is yours. You have 10 minutes. And 1 minute before your time finishes, I will point out about the time you have to conclude your talk. Thank you very much.
Okay, thank you very much. I hope you can see my slides and you can hear me, right? Hello, can you hear me?
Yes, the slide.
Yes, we can get you.
Yeah,
okay.
We can hear you.
Okay. Okay, thank you. So, yes, my name is Miguel, and today I'm going to talk about this small research we are conducting here in Namibia to try to predict and describe droughts using different mathematical methods and the combination of them. Let me introduce a bit how is the rainfall situation in Namibia. Namibia is a very arid, semi-arid country with many problems derived from extreme climate conditions like droughts and flooding. This extreme rainfall situation affect the many aspects of the economy and the livelihood in Namibia, like food security, animal health, access to water, especially in rural areas, but also in big towns, quality of grasslands, and many other aspects, matters are fully dependent on the water rainfall. So since we cannot just create or stop a rainfall, the approach we are trying to follow is try to understand the drought patterns and if possible, make prediction models. So in this slide, I just want to show how is the situation in Namibia and how heterogeneous, how different it is, both geographically, but also in the temporal scale. On the left side, we can see towards the north of Namibia, in the border to Angola, there is a subtropical climate with more than 700 millimeters per year, while in towards to the coast and the south, the rainfall is below 200 millimeters, with many years with zero rainfall. On the right image, we can see an overview of the drought incidents in the 20th century. So we can see this is also quite heterogeneous, with some decades with a huge accumulated drought impact, which is shown by these yellow balls, while in many other decades the incidence or the drought severity is lower, and this is only showing in terms of decades. But if we check also the annual incidence is also quite heterogeneous. So, as we know, climate forecasting models become very complicated mathematically, since there are many factors involving atmospheric phenomena, dynamic of the oceans, also relative position of the sun and the earth, and for sure also the local topography. So, and they normally calculate or take into account long-term trends or just short-term forecasting or prediction of a few days or maybe 1 month maximum. But our approach or problem is actually a bit specific and a bit different. We just want to simplify the forecasting just to try to understand what is the probability of having a drought within a specific time period. So since our problem is very local and also very specific, we just try to also create our own simple methodologies. So the first thing we did is basically assume that a drought is a rare event, and we assumed it can follow a Poisson distribution. So entering rainfall data, assuming that 1 year is one temporal unit, we enter the rainfall information into this Poisson model, where R is the number of events, T is the time where we want to consider the probability to have a drought, and lambda is the intensity. So basically the number of events per total number of years. And we basically created these curves that you see in the lower right side, basically where we enter the number of a specific time frame, for example, 5 years, and then we retrieve a specific probability to have 1, 2, or 3 droughts within this time frame. But at the end of the day, this is just a descriptive model. We cannot make predictions with this methodology. So, but we still using the same Poisson model. We just modified, or we just make it dynamic, some of the parameters within the model to estimate, to make simple predictions. For example, if we start the time series with no drought, lambda is 0 because they are not, the intensity of the rate is 0. As 1 drought is detected, there is 1/4 drought, so 1 drought in 4 years. And imagine now we want to make a prediction. So what we for maybe 2 years after that drought. So we need to consider the 2 years before the present plus the 4 years when for the prediction, to make the prediction. So the total will be 6 years, and these parameters are entered into the Poisson model in order to estimate or just derive a probability. So this is basically what we did in this first component. And here in this slide, you can see some of the results. Yeah. So the blue line is the probability. The orange dots are the droughts. And yeah, I think there are a few interesting things we can see here. For example, that there is a separation, a clustering between the probability which is assigned to a drought, to when the drought is occur. The probability of the model is the curve is shifted to the right in comparison to those years when there is no drought. Also, I think in the second case, sorry, these two are actually two different locations, two different climate stations. Yeah, one in the north and the second one, Nimruz, in the south. So we can also see that this method captures the change in the incidence of the drought. So if there is a higher incidence in the drought, this tendency will be also captured by the Poisson model. On the map on the right side, we can also see estimation of the accuracy of the models for the different climate stations in Namibia, and we can also kind of extract from this map that the drier areas towards the coast and also the south are more predictable in general than those in the center and in the north or the northeast. So, but of course, we cannot rely only on the stats and the statistics to make those predictions. We know the drought incidence is a consequence of global and local atmospheric phenomena. So we just wanted to introduce El Niño, La Niña alternance or incidence of this data into a simple model, machine learning model, just to see what is the real impact, because this is also one of the feedbacks we are always getting when we are trying to develop these methods. But also the local ones like the Angola low and Botswana high, these pressure systems in the area, according to the literature, they also have an incidence on the drought occurrence. So basically,
hi, Miguel.
Yes.
I just want you to know that you have two more minutes to go.
Okay, thank you. I'm almost done. Thank you very much. So here, basically, this is what we did. We just use a logistic regression to calculate the probability of having a drought or not, and using as training data this El Niño, La Niña patterns, yeah, and the drought incidence, of course, the drought occurrence, in order to be able to make some predictions, and with the aim in future to also include the Angola low or the Botswana high data sets. So these are the results. Just quickly, I just would like to mention that yeah, the results can be improved, but we were able to detect 42% of the droughts with this method and 55% of drought or no drought. So the total accuracy is around 55%. We still need to refine it. Also important to mention is La Niña was actually quite consistent as an indicator, but in a reverse way. So that means La Niña in Namibia is an indicator of no drought or just a good rainfall year. The idea now is to work in parallel with these two models and integrate them into a Kalman filter, which is actually quite good to model dynamic systems. So the idea is to maintain a state vector, which are the probabilities coming from the two different methods, and the Kalman filter for each time stamp or for each moment will kind of balance or take the method with the lower error. So this is basically where we are now, where we are trying to develop the next steps, and yeah, hopefully once this thing is finished, this is my last slide, sorry, we'll, yeah, basically our work now is focused on just refining the logistic or the machine learning regression model, just adding more factors and try to, as I said, to increase the accuracy, also integrate everything into the Kalman filter, and finally produce a tool which is useful for the farmers basically just something that they can open in the smartphone just to select the type of event, how many events they want to predict or to detect, and the time frame, the number of years, and for sure the location of the farm to derive a probability of having, for example, 1 or 2 droughts in 10 years, and if possible also an associated errors for this prediction. And this is my presentation. Thank you very much.
Thank you very much, Miguel. Thanks for being time as well. And please send your comments, your questions in the chat box. And we already have one from Andreas, so then we will get back to that when all the presentations are done. So I will be introducing to you our next presenter, Dr. Sebastian Riera. He is the postdoctoral researcher at the National University of Cuyo Rectorado, Argentina. He has got his PhD in agricultural economics from the University of Göttingen in Germany. So he's going to talk about the topic, water talks, how information flow can enhance governance. The floor is yours.
Many thanks for the presentation. I have opened the PDF, and I will thank Miguel when he can turn off his screen sharing.
Sorry.
Great. Perfect. Thank you. Thank you for the presentation. Then I'll go straight to the talk. We're going to be reviewing preliminary research results named Water Talks and How Information Flow Can Enhance Governance.
Sebastian, can I ask if you do the full screen? I guess this is some like making the slides very, very small when you have this like side.
May I interrupt? I'm sorry. It's Verena from Technical Support. This is the presenter's view for all speakers. For the audience, there's only this one big slide in the middle. For the speakers, there is no other view. I'm very sorry. The tool limits us a bit.
No, thank you.
Great. Thanks, Verena. Great. Well, this presentation was based in Mendoza, Argentina, which is located central west, and that is a semi-arid area. And let me just quickly drive you through the introduction. As we all settle in this work, we know that adaptation is key to overcome the challenges posed by climate change. Well, agriculture and agro-industries is central in the arid Andes and very much depend on the water resources. Mendoza holds the oldest constitution in the Americas on water resources, and this constitution tries to set base for a bottom-up approach, ensuring stakeholder participation and engagement in the process. Well, despite this legislation, there has been an increase in demand of technicians and practitioners. So this will allow a better interaction with the, sorry, let me get that straightforward. There's a need for increased capacity building in technicians and practitioners for improved water management and acknowledges all these challenges in the process. So we understand that the social network approach contributes to build the cornerstones of information flow by identifying the strength bonds and bottlenecks of water management system. So basically what we did is taking advantage of the capacity building course of technicians and potential practitioners. We assess their interactions. We ask them to complete a survey, online survey, and we focus on two sorts of types or interactions. The non-directed network, this will be the pre-existent communications before the meeting, and the directed networks, where we illustrate and we ask them for a statement regarding specific topics, if they talk to the peers about specific topics. These topics, where, as you can see, they are detailed there, are 5 main topics: water distribution, markets prospect for agro-industries, climate contingencies, irrigation practices, and input prices. As mentioned, the data was collected through this capacity building. This was a 4-month course, and we used a digital platform, and that was in the south of the province of Mendoza. Some of the results are shown right here. This is the network for San Rafael Basin. It looks like a bunch of flowers in a garden, but pretty much tells us that each dot, there's a square dot are males and circle dots are females. And each of the topics are linked whenever they talk to each other. For example, for instance, there's only a green light. That would mean these people are only talking about market prospects. On the other side, some of the center dots, they're really talking about many other issues, and that will be relevant for all the interactions that are being necessary or need to be tackled. As we can see, there are some dots that are a little bit isolated, and that could be this green dot right here that it's pretty much isolated, but they are only talking about market prospects. Whereas there are other dots that are pretty much central, and we can see because they are circle dots that they are mostly linked female participants in the market. This next slide will show us how this small sample is distributed within the San Rafael Basin, and we see some connections, and we see also some isolated dots that need to be retaken into consideration. About these dots, they are all not participating on input prices, they're not participating in climate change, they're somehow participating when it comes to irrigation practices. Some of them are being included, and so on. This was in the San Rafael network, and we'll move into the results for the Atuel River Basin. I added some stats of the results right here. Same as before, we have in this case, we have a less populated network, and we do see some effects on the statistics, on the spatial temporal statistics, where we say, okay, for example, in terms of water distribution, people that are talked about water distribution, they simultaneously talk about any other topic, but people that talk about water distribution, they talked pretty much is included in other sort of conversation. Revisiting the graph from the previous results, we see some connections, we see some central dots below the right, and female participation is quite important. It should be fostered in this case. And this will lead, maybe I went quite too quick, so this will lead to the results. And on the results, we say that when people talk about any other topic in these conversations, they also include water distribution. But we see that people that mainly talk about water distribution do not talk about any other issue. So generally speaking, water distribution, it is the core of the conversations in this network. This is quite important because we are settled, all the stakeholders, they need to talk about water distribution as they are entailed by the law to do so or participate in so. But we didn't see much participation on irrigation practices. So they much care about how water is being distributed in the network. They're not improving how they can improve, or they're not talking how can they improve the irrigation practices. This points out the signal for decision making so they can tailor policies more accordingly. Interesting, but not wouldn't avoid to talk about this, is that the established links, so existing connections, are sealed, but they're still spreading information. This is something to be focused on, since networks could be somehow closed for newcomers, as they might have difficulties to enter, or who they have to talk about it, or who they can learn about it. And much going forward, then key stakeholders shall be endowed to deliver information more specifically. And we focus
Sebastian, again.
Yep.
You have less than 2 minutes to go. Sorry.
Takeaways. Basically repeating myself, I hope not much more clear. Water distribution is central in the conversation, but irrigation practices are less frequently discussed. We have less open network for newcomers. Women are consulted less regarding regarding water-related aspects, they are consulted less. If it comes to climate contingencies, or if it comes to market prices, they are women empowerment in the sector. And we want to acknowledge, last but not least, the Departamento General de Irrigación, who provide us all the tools to move forward on this research. Then, thank you very much. This was quick, but I'm open for questions or comments. Thank you.
Thank you very much, Sebastian. And as it is mentioned, so for just not mixing up the questions, and if you have a question towards a specific presenter, please just add like @ and they mention the name of the presenter, then they know which question is addressing to them. So we will have our next presentation. We have Saul Arciniega Esparza, if I am pronouncing it correctly. He's going to talk about the development of water balance web application for Costa Rica using open source and global data.
Okay.
Please, go ahead.
Can you hear me?
Yeah, all clear.
Okay.
Very good.
Okay, thanks for the introduction. My name is Saul Arciniega, and I am professor at the Faculty of Engineering of the National Autonomous University of Mexico. And as you can see, I'm going to talk about the development of a water balance application for Costa Rica using open source and global data. This is the content of this presentation. It is divided in 5 sections, and we have the introduction, objectives, data and tools, and the development of the water balance application. And finally, the conclusions. Oh, sorry. Okay. As you know, there are many gaps in data and knowledge for hydrological modeling in regions like Latin America. Some of them are the lack of data to calibrate and validate hydrological models that increase the uncertainty of complex models. Also, different problems have been found with in situ climatological records. One example of that is shown by Westenberg and Birkel that corrected the precipitation in catchments of Costa Rica to improve the water balance simulation, as you can see in the plot in this slide. Also, other point is that hydrological results are complex models demands technical skills to understand and to analyze such kind of data. So in many cases, share the information with decision makers and non-expert people is quite complicated. What are the solutions for these kind of problems? Well, first, currently we have more remote sensing data and global products of climatological and hydrological variables for large periods with global extension. These kind of products have been applied in different regions for different purposes, such as hydrological modeling. Also, several hydrological models have been developed during the last years to deal with the lack of data. Science incorporate techniques for regional modeling. And finally, during the last years, we observed important advances of tools to develop data science and decision support application with less code. As example, this water balance app in this slide was made with some web services to share the land surface model results, making accessible the information for non-expert people. So the objectives of this work are apply a large-scale hydrological model to assess the water balance in Costa Rica using local and global products to force and calibrate model, and develop an interactive web application as a tool for decision support and educational purposes. The study area then is Costa Rica, a tropical region with a precipitation over the 3,000 millimeters per year. Here, we are modeling more than 600 nested catchments, as you can see in the map, as gray polygons. We are using shears precipitation product with a bias correction using 76 ground stations. And for the calibration of the model, we used 13 stream flow stations with daily records from 1990 to 2003. They are shown as black dots in the map. Also, we are using for calibration monthly potential evapotranspiration and actual evapotranspiration from MODIS for the period 2001 to 2014. And we are using different calibration strategies to deal with the uncertainty of the model. Okay, this is the model that we are using. It is the hydrological predictions for environment, the height model. This is an open source model that you can download using the link below in the slide, as you can see here in green. And height is a semi-distribute and process-based model with some operational characteristics, as well as some capabilities to predict hydrological signatures in engaged catchments. These are the tools that we are using for the development of the application. We are using SDGs for the geospatial analysis. We are using the height model that I described before. Python was used for the automatization and development of this platform. And Plotty and Dash are libraries for interactive plots and scientific dashboard development with low code. And Gitbook was used for the development documentation and was preferred since it allows markdown syntaxes, and it is free. In the free account, we dispose of 10 interactive books. And finally, Heroku is a platform as a service for web development, and this Heroku allows easy development, and we dispose of a free account to launch small applications. Okay, here you have the results of the model. We found that height was successfully applied in catchments of Costa Rica. Our results suggest good performance with a clean Gupta efficiency of over 0.6 using monthly stream flow. And as you can observe in the maps of this slide, height is able to preserve different hydrological signatures such as base flow, stream flow coefficient, evaporative index, and RET index. I don't know if I can make a kind of a mark. Okay, I think. Okay, in the fifth row, you can observe the signatures using the observed data. And the second row is the modeling signatures. Also, we found that using stream flow and evapotranspiration for calibration improved the simulation of the water balance. Using the results of the height model, we developed the web application using the tools showed before. This app is available from the link showed in the green part, in the green text, and has been documented for non-expert people, for decision makers, and also for students, for education purposes. I think that I can share the link in the chat if you want to take a look. And also, this app is available from the link. Okay, the application is fully interactive and allows to explore and download the hydrological results of the model. And today, This application has been used for academic purposes to show the variability of hydrological processes at concrete.
Excuse me, just to let you know, you have 1 minute, 30 seconds less than that to go. Yeah.
I will finish soon. Okay, but also it has been shown to decision makers to explore the possibilities to use this kind of tools for water management in different regions of Latin America. Okay, as conclusions, HYDE model was successfully applied in a high-resolution large-scale model in Costa Rica. Several tools are now available to develop a more interactive platforms with low cost and time. And tools for decision support and education are required today to communicate the needs of water management. And finally, the tools presented here are open source and free, so you can use them for your own projects or research. So thanks, that's all.
Thank you very much, Saul. It was a very interesting presentation. Thanks for being in time as well. I am introducing to you our next presenter. I am trying my best to pronounce the name correctly. Jorge Sarmiento. He's pursuing his PhD in applied ecology at University of Sao Paulo, Brazil. And he has worked with international projects such as Latin American Water Fund partnership in the Nature Conservancy. He's going to talk about artificial neural network, closing the gap between big global data and local environmental challenges. Very interesting topic, and looking forward to hear your presentation. Please go ahead, floor is yours.
Thank you, Mahsa. Can you hear me?
Yes.
Yes, everything working. Okay, good, perfect. So we are living in the era of big data. In the sector of Earth observation, we have organizations like NASA, that generate more than 12 terabytes of data every day with all of their missions together. From the European side, we have with ESA, with the Copernicus mission, more than 15 terabytes of new data generated every day. When you combine both public and private sector, there are more than 3,000 Earth imagery and meteorological satellites orbiting the planet every day. So it's not about data anymore. Now the challenge is finding an efficient, fast, adaptable, and replicable approach to extract information for decision making from this huge body of data. Okay, so now you might be asking yourself, okay, what is that YouTube logo doing in this slide and with this 23 terabytes of data? Well, the thing is because YouTube faces a similar challenge. Every day, thousands of YouTubers, instead of satellites, are generating data, videos, instead of landscape images that needs to be transformed into useful information for decision making. Basically, they're trying to predict what you want to watch next. So the way that YouTube does this is by using a deep learning general purpose approach for solve these learning and prediction problems. And they are solving this by basically using machine learning. So this is the paradigm that big tech is using to face big data challenges. One body of data, one general purpose approach, tailor-made solutions for each of the viewer problem or challenge. So I'm going to talk about 3 study cases where this kind of big data paradigm is applied for environmental challenges or problems or questions. So between the years 2013 to 2015, Sao Paulo in Brazil, a mega city with more than 12 million inhabitants, faced a water crisis due to what now is concerned is accepted as a meso-scale climatic event. In this study case, we use a deep neural network. We trained this neural network to try to forecast the river discharge during the crisis. It was trained using only remote sensing data and using only 3 years of data immediately before the water crisis start. The objective was to find if the neural network can predict the severity of the discharge reduction in the river that flows into the principal reservoir of Sao Paulo city. And for the sake of comparison, the neural network model that we create was compared against the discharge time series generated by the Sao Paulo water company hydrological model, which is a HEC-HMS implementation that is running on 30 years of climate data from meteorological stations. As you can see in the plot, the neural network model discharge, and this is the red dotted line, was really close to the actual measured discharge, the bold blue line. No? This means that the neural network can accurately predict the severity of the drought during the worst period of the crisis, which is inside the green box in the plot. And this also shows that the neural network model is outperforming the HEC-HMS methodological modeling, both at predicting the severity of the drought and the beginning date of the most severe discharge reduction in the period. No? The HEC model predicted the sharp discharge reduction around week 50, while it actually started around week 30. No? What does this mean for actual decision making? Well, basically, on the model that you use, you can have a 10-week time window for planning or not, based on the source of information that you use. So the question for me was, how can a neural network that was trained only on 3 years of data outperform a hydrological model trained on 30 years of data to predict the intensity and the beginning of the drought? No? And I found that maybe it's because of 3 main reasons. No? The first one is that the neural network is using actual measurements from satellite or remote sensing data instead of estimations. No? For instance, the neural network can read directly the light absorbance and the chlorophyll absorption wavelength and the foliage, the vegetation temperature using infrared wavelengths. No? And then infer that the difference between the water that you get from the precipitation and the water that you get on the river discharge is somehow related with the vegetation activity and the vegetation vigor. No? Instead, when you have a traditional hydrological model, you need to estimate the evapotranspiration. You need to tell the model the temperature, solar radiation, maybe use some kind of Penrose-Montiel equation, and then throw in some coefficient to get the water consumed by vegetation. No, in the neural network, it just takes it directly from the imagery. No, the second source of the difference of the outperformance is related with the consistency of the data. No, the precipitation data from satellites gets the whole picture for the whole study area every hour, every day, with the same precision for all locations in the basin. No, this is a consistency that has this time series that usually you don't get on automatic, even with automatic, and especially with manual meteorological stations. This consistency is unknown. No? And the third reason is the variety of data. No? Neural network can ingest any kind of data. No? Even things that we consider redundant from the point of view of the neural network are complementary information sources. No? The neural network that was used on this application used 2 different precipitation information data sources at the same time in the same model. No, use it Persian and Churs. No, and for the neural network, there are just 2 different readings and factors. No, and any bias between the data sources and the actual measurements, the neural network takes care of that, not during the calibration process. The second study case I'm going to show you is related with, again, time series modeling, but in a much smaller and very different ecosystem. No? This is a picture from the Yeso Reservoir in the Maipo River Valley in Santiago de Chile. If you have ever drank a glass of Chilean wine, most likely it came from this watershed. Located in the high Andes Mountains, this reservoir, the one in the left, collects water from snow melting and precipitation. The picture on the right corresponds to Casa de Piedra wetland. This is a small 32 hectares wetland that buffers and removes sediments from the water before it reaches the reservoir. In this wetland, the Nature Conservancy have been monitoring groundwater level dynamics since years 2015. Basically, all the water that is in the reservoir today was first stored, filtered, and naturally released by the wetlands located in the high mountain valleys above the reservoir. So Understanding the water storage dynamics in these wetlands is then key to forecast how much water and when it will be available for downstream users. And of course, as you can see in the pictures, being this a high mountain ecosystem, understanding how snow melt dynamics are changing due to increasing temperatures, it's important to forecast possible changes in the water supply regime as a consequence of climate change.
George, you have
Good.
less. Yeah.
So the objective was to try to see if the same paradigm from Sao Paulo case can be applied here, no? And basically the short answer is yes, not as good as in Sao Paulo, but somehow better than what we can get from a hydrological model with the limited data availability that we have in this landscape, no? And the third study case I'm going to show today is again from this study site, but this is related with monitoring using imagery. Now, in this same place where we have gathering this information, this time series information, we also have a time-lapse camera that have been working for 5 years, taking one picture every 15 minutes. No? So it's a lot of information, but it's challenging to extract valuable information from this data. No? So what we are doing here is using another kind of convolutional neural network, convolutional neural network, to detect the objects on the wetland, no? Detect the tourists, detect the cars, detect the cows and the horses that are overgrazing the pasture, and then tabulate all of this information in time series that you can use to get things like what is the average time visit, what is the number of cows and horses that are grazing in this area, how much time do they spend in this wetland. And now we're training this another neural network on identifying flow dynamics, identify what's happening on this small creek that you see in the picture, when you have a flood or when you have another kind of event. So working up, the big data paradigm is basically how can you use one general purpose framework to get custom tailor-made solutions from the same body of data, but for a variety of users, And the first two applications, the one in Sao Paulo and the one in Chile, they use exactly the same body of data and the same neural network. It was basically the same architecture. The only thing that was different was what the neural network was trying to predict. For you, discharge. For you, groundwater levels, And the second point is that technology transfers of deep learning solutions from our sector of industries is something that is really worth exploring in the water resources sector, because it can really open the doors to us to get a lot of new information from data pools that are there but are under use. They are not properly used. We're not taking really the advantage that we can take from them. So thank you very much for your attention. On behalf of Mahsa and myself. Thank you, Mahsa. Thank you, everybody.
Thank you very much. So we have our 4 presentations. So we have 2 also, as I said, short presentation on poster. Well, I am introducing to you our next poster presenter, Chomba Innocent. He is the PhD scholar at the University of Zambia at the Upper Zambezi Basin project. So also he's also young water professional in the Ministry of Water Resources and Development in Zambia. So he's going to introduce to you his work and his research in a poster format. Innocent, please.
Okay, thank you very much. Are you able to get me? Okay, so basically, as the introduction, my name is Innocent Chomba, a PhD student working on the project in the Upper Zambezi. So what we're trying to do in this project is to try to understand the hydrology of the Barotse floodplain. So the Barotse floodplain is what you're seeing on the first slide, which is indicated in blue. It is the western province of Zambia. It is part of the Upper Zambezi, which is in black on the western part of Zambia. So what we're trying to do is to come up with a coupled model between hydrology as well as hydraulics, so that we'll be able to get some results from what we'll be looking at. So basically, the biospheric floodplain is important for the people because it has a number of ecosystem services for the people. People are using it for water and sanitation issues. People are using it for agriculture and livestock. It's also used for ceremonies like Komboka ceremony, which is a very famous ceremony. Despite the COVID, we couldn't have it this year. It has a lot of rich biodiversity which supports the aquatic ecosystem. But all these are being threatened with regard to climate change, and it's having impact on the hydrology as well as the hydraulics. So the idea is, the objective of this work is basically to develop a coupled hydrologic and hydraulic models so that we should be able to understand the hydrology of the biospheric floodplain better than in the way it is. So currently, the modeling that is being done in the biospheric floodplain is, we are seeing a number of hydrological models that have been put forward, and what we have is a classical modeling where the hydrology feeds into the hydraulics, but there's no feedback mechanism to say what if there's infiltration, what happens? Do we still get, for example, same inundation extent? Do you still get, for example, same discharges? Do we still get the same results from the simulations? So the idea is, can we come up with a coupled model and see if we can contribute to the improvement in the understanding of how the hydrology of the biospheric floodplain can be described. So currently, we're also getting data or information which we'll use for validation as we go ahead with this project. We are getting the discharge data or flow data from installed gauge stations. We're trying to get groundwater levels from monitoring bores as well. Also going to use a lot of images in order to compare the inundation extents with what we'll be getting from the model. So with regard to that, what the stage where we are now, we have the entire coupled framework set up now for the models. So we have set up 2 experiments which are working. So the 2 experiments, basically, we have got one which is the view flow, which is an hydraulic model, is fed into a risk flood model, which is an hydraulic model in a one-way direction. But also I've got the 2-way direction where our research is trying to focus more, where the hydrology feeds into hydraulics, but as well the hydraulics feeds back into the hydrology. So that we see, we capture more processes and compare it with the one-way direction and see how best we can describe this. So this is
Innocent. I have to ask for concluding here because it is already more than 2 minutes that you have taken your time. So it would be great if you're getting to the conclusion, the last statement, please.
Yeah, so the last statement basically is, we have the coupled model which is in place, and this is the very first coupled model that we are developing, and we are able to do fully validation as well as calibration of this model. But that's what we are currently working on, and see how best we move forward from here. Thank you very much.
Thank you. Well, last but not least, we have our last poster presenter. I'm introducing you Diane Apriadi. She's finalizing her PhD at Urban Water Management Department of Technical University of Berlin, and she's going to share with you some part of her research. And Diane, you have 2 minutes.
Oh my God! Okay, it's okay. Hi guys, I'm Diane Apriadi. Thank you so much for giving me a chance. Today, I would like to introduce my research topic about the research and support system that help stakeholders with selecting the best sanitation solution for an urban slum area. So this research already like 4 years, and yeah, so like the slum area, as you know, like this is not a new phenomenon. Like currently, right now, it's like 1.6 people still living in the population, like in the unhealthy life, like, and also like a crowded and unsafe housing. So sanitation is also one of the indicators that detecting the slum area. There are many slum dwellers still inadequate sanitation. So this research is like providing the recommendation, like about the web-based decision making or decision support system people for stakeholders to select the efficient system for domestic wastewater treatment in slum area. Right now, it's working in Indonesia. Yeah. Then my methodology is a design thinking. Maybe it's new, but like a bit complicated, but a bit more social. So first we identify the stakeholders and the problem. Then we start designing the solution using the technique like a brainstorming and storyboard, if you can see like from my slide. And after it, several iterations, we continue with digital prototyping. So at the beginning, I used Excel, like a Visual Basic, but right now, same like Saul. So like I also like develop the web app for the decision maker in Indonesia. Yeah, the last step is like a testing and evaluation for our prototype. The new things from this research, like for the regarding the literature, I trained the machine learning algorithm to calculate the relevance of the publication for my topic, and then also to reduce the bias. Then yeah, then this is the result. Like here comes the result. Like this digital prototype. I cannot show you right now, because, but like this is just only like the how does it works. First, like you will answering the questionnaire. Like we already test the questionnaire, and then it takes like about 5 minutes. And then using the answer of that, automatically eliminate unfitting technologies in the back end, and then showing the remaining solution of the user, and then allowing them to highlight preferred technology. And then at the end, it's like presenting the final solution to the user. It balances the need of the high economic and then the high at the low complexity, because we define that's the sustainable aspect for the slum area. And then the conclusion right now, like our test from my app, it's called like upgrading slum sanitation, like show that user-friendly UPSS can successfully support the user to understand and choose the best and most sustainable technologies for slum area. And then the web application can save the history of the user input and selection, so that can be easily shared with the government institution for the next step of the implementing of the new sanitation technology. As you can see, also, you can see like my result is my research is support the SDGs number 6, like a 6.2, like sanitation management, and also like number 11 to upgrading slum income, yeah, and slum area. So far, that's the result. The result. For further information, you can contact me directly. I'm sorry, quite fast because I have 2 minutes. Thank you. Yeah.
Thank you very much, Diane. So since we start our session 10 minutes late, we already have like 10 minutes for concluding the session and answer to some of the questions that we already have. So I just want to fast move to Miguel. Just please reply back to Andreas, and you had another one question to refer to. So please, if you do it, so if there is any more, please leave it in the chat box, and then we can see who could be next to answer yours. Please go ahead.
Okay, thank you very much for the question. Yes, actually the recommendations will be in the line of deciding number of cattle to have in the farms, which is always a big issue to take this decision. Which also have a huge incidence in the price of the meat in the meat market. Very important is recommendations also related to the water use in the dams, because at the end of the day, water is scarce. It's very important, so you don't want to use more water than what is actually secure. But also you don't want to use less, because the water is very needed. Type of crop also, if there is expected a dry cycle or a couple of droughts in the next 5 years, maybe the crop should be changed, for example, to maize, which is not the favorite of the people in the north who are doing the rain-fed crop agriculture. They prefer permillet, but the reality is that they lose the crops many years due to the drought. Yeah, so I think recommendation will be basically in this line. Yeah.
Thank you very much. I want to ask, I think just like we have like one question to Sebastian, I guess, right? Is there anything that you want to add from the comments you get from the audience, or just like say like some concluding remarks before we end the session? Sebastian, I meant you, but I guess you're just...
Sorry.
Yeah, but if you no worries, but then if there is any, just wanted to go.
I wanted to respond to Diane's question regarding the group discussion. I couldn't fully understand understand the question if the highlight topic was given by me or if that was on the data collection process.
I mean, like during the social network analysis, like you also have this kind of the focus group discussion, right?
Answer.
Yeah. So like my question is like how you can divine the like a water practice, like they discuss about this topic and then water and then the other stakeholder like highlight this kind of topic, or are you just observe their discussion or you provide a question, something like that?
I guess Sebastian is disconnected. Or he's back. So we can wait for him to come back. Meanwhile, I just recognized that Innocent also sent a question. So Innocent, you want to ask? I guess your question was towards Saul, right?
For so I was just asking for the email so that probably can get.
We were talking about something about validating the result of the research. That was the point,
yeah,
right?
That was the first presentation for Miguel.
So then okay. Just wanted to make sure that it was answered. Well, okay, Sebastian, are you with us or can you hear us?
I am with you. I can hear you. I hope you can hear me.
Yes, we can't see your video, but then because you are in the middle of a talk with Diane, so let's see. You can continue, please.
Okay. We proposed their topic, and we said, okay, if you knew each other, which conversation you had before the course, before the capacity building, and which conversations were had after this capacity building, so after they finally knew each other. And using that, we run this model on network analysis, and those are the results that were shared. Thanks.
Thank you. If any of you have some concluding remarks, we don't have any questions from the audience anymore. I hope I just addressed all which were there. If there is any, please point out. But if not, if our presenters have any concluding remarks, so then I would like to hear from Saul if there is anything you want to add before we concluding the session. Saul, can you hear us?
Yes, sorry. I was writing my email in the chat.
Okay.
So I think that it is done.
Well, apparently there is nothing. Jorge, you're up next. If it is anything that you want to add up, if that is something.
Yes, I saw in the whole session, in the whole conference, several presentations regarding machine learning applications around water security. I think we can think about having a specific session on that topic the next year, no? Machine learning in water application, no? Because it's huge, no? If you count, it's more like, I count 12 sessions, 12 presentations on machine learning topics, so it's huge.
I totally agree. Diane, Innocent, I don't see Innocent anymore, but then Diane, if you want to conclude something.
Thank you. Yeah, I completely agree with your about this because like mostly we always talking about industry 4.0, for example, like fear null, then, but yeah, but people people should know like how the data, how the remote sensing, how the water can integrate, like the machine learning can integrate the information. So it's not only you just go to the web app or something like that. They should also know the transparent information behind it. yeah, I completely agree. If we can have this specific, not a conference, like maybe something like the new agenda about it.
I totally agree. This session that we organized today and you are presenting in was the idea was started to have something on smart water solutions and digital technologies and water sectors and climate. Last year in Mexico, the last Water Security and Climate Change Conference. So that was the idea. So I hope even in this series of conferences and also in others, we have more focus on bringing in the digital technologies and the idea and evolving role that they are playing in water sector for just even bring the understanding awareness of that existing these technologies to being applicable to different sectors and domains of water security. So, and we know the huge gap. For example, there are lots of like misunderstanding, there are lots of gaps in knowledge and awareness about these things among different water actors. So we really need to promote those ideas, to present more and make sure they are going to be applied in a sustainable manner to make sure it is not going to be new added challenge to the water sector. So there is, we have to conclude the session because there is going to be the wrap up of the afternoon sessions and continuous of the program. Thank you all for presenting and hope to see you in person soon, the next event. And also thanks from thanks to the audience for participating.